Hello, my name is Max, and today we're going to be talking a little bit more about how negative numbers work. Last time, I kind of gave the reasoning of why we want them, like how we came to discover them. But today I'm going to go a little bit more into proving why that is. So first off, we see that this what we know is a negative sign. This denotes the inverse. That's all we're going to say. It's the inverse of a number, say n, such that negative n plus n equals 0. That's all we're saying. That's all we're saying, that negative n plus n equals 0. We're going to call this negative n the additive inverse of n. Now, and what we want is we're going to assume that negative n holds all of our properties of addition that we've previously used. And we're going to see what properties come as a consequence of that. So first off, we can just use our commutative property to switch these around and see that negative n is, n is the additive inverse of negative n, just as negative n is the additive inverse of n. Now, that was kind of a mess of words, but basically what I was saying is that negative of negative n equals n. Basically, applying a negative twice cancels it out. Easy stuff, right? One more thing. I need to stop saying the words "one more thing" while I'm not still at the start of the video. So what we want to do next is prove that for every number, it only has one additive inverse. So we're going to prove this by contradiction. We're going to say for some number n plus negative n 1, because we're going to assume that it has two additive inverses and show that they're equal to each other, then this equals 0 by the definition of an additive inverse. And for n plus negative n 2, that was a terrible n, but you get the gist, 0, then that also is true. And what you can see is that these both equal 0, so we can just set them equal to each other. So we get, I'll speed this up a little bit here. So we get that. And what we can do here is we can just add negative n something. It just needs to be an additive inverse of n to both sides. So both of these n's cancel out. So what we're left with is negative n 1 equals negative n 2. So both additive inverses are provably equal to each other. So what we can say with that proof is that n has only one unique additive inverse. So pretty nice. Let's get rid of that. We're done with that. Next thing we want to prove is how adding two negative numbers works. So we'll start with something simple, such that a plus b equals n. That's just what we're starting with. Doesn't really mean anything. There's just some number a and some number b, and they add together to n. Now what we're going to do from here is we're going to negate both sides. We're going to add a negative sign. Negative a plus b equals negative n. And we're gonna ignore this side. We're just gonna manipulate the right side. So I'm just gonna draw this one equal sign here. And we're gonna add 0 twice to the right side. Plus 0. And we can do that because, anything plus 0, it's still the number. It's the additive identity. So, and what we're going to do with those zeros is we're going to use this property of additive inverses, and we're going to add negative a plus b and negative b plus b. Now, it's going to take a little bit to write this out, so I'll do it quick. Okay, that is what our equation turns out to be. And that may seem kind of strange, but I'm going to move around this equation using our associative and commutative properties of addition. And hopefully after that, you'll kind of see where we're going with this. Okay, so what we did here is that we moved a and b together, and we moved negative a and negative b together. And what comes of this is we have a plus b here together. And if we look backwards in our sort of work, we see that a plus b equals n. So we can just cross this out and substitute n. And you see here that we have a negative n and an n. And we know, because those are additive inverses of each other, that that is 0. So what we end up with, because those cancel out, we just end up with negative a plus negative b. Very nice. And remember, we're all saying this is equal to negative a plus b. So what this is saying, I'll write it out over here. Let's just remove all this junk. Get rid of all of it. Is we're saying that negative a plus b equals negative a plus negative b. Very nice. Basically what you can see this is saying is that the negative sign sort of distributes over addition. And this is very useful as it gives us a way to add negative numbers. So say we were doing negative 1 plus, let me do a little bit better job drawing here, negative 1 plus negative 2, that would be equivalent to negative 1 plus 2, or negative 3. Very nice. Very useful sort of definition. Now, one last thing, I think, I'm pretty sure this is the last thing we need to talk about, is that we can also define sort of, what am I trying to say? Sort of like negative number plus a non-negative number, not of just the same number. So say we have some number a, and we're going to start with, maybe it'd be better if I show you an actual example instead of variables. So we'll start with 2 plus negative 2 plus negative 2 equals 0. So we know this is true because they're just additive inverses of each other. And what we're going to do is we're going to add, I don't know, let's say we're just going to add 1. We're just going to add 1 to each side of the equation. So we're going to get 1 plus 2 plus negative 2 equals 1. Now what we can do is there's nothing stopping us from just adding those 1 and 2 together. So what we end up with is 3 plus negative 2 equals 1. Now, using that same process, we can define adding some number and some negative number, and it'd be fine. We can define all of that. So that makes it so that all of our negative numbers are sort of complete with all our natural numbers. And once again, we're going to call all of these the integers, all the negative, non-negative numbers, which is kind of defined as like, let me see if I can think of a set theoretical definition of this. You can sort of think of it as the set of all natural numbers in the union of the additive inverse of all those natural numbers is the best way I could put it. So yeah, I think that was all I want to talk about today. Next time, we're going to be talking about series and summation notation. So yeah, good burr.